In the example that you have, a portion of the graph of a periodic function f is shown above. What is the least possible value for this period? To determine the least possible value, one is simply I recommend using a max and a min and identifying what the distance between that max to the next max is, or the min to the next min. Like here, I would use this value to that value right there and figure out what that distance is. So from left to right, since we're going from -3 pi over 2 to pi over 2, to figure out the distance between those two x values, I would simply subtract them. So which is pi over 2, and since I'm subtracting a negative, that's the same thing as adding a positive, and these two things add together by adding the numerator, so we end up with 4 pi divided by 2, which is equal to 2 pi. So that's the period. So the distance from one point to another point when the cycle repeats is a length of 2 pi units. Now, how can we use this in order to figure out what the value of f of 10 pi is? Well, since we're going the domain indicated here is from -2 pi to +2 pi, I would simply add or subtract again the period till I get to a point that's here. So I'm going to subtract 10 pi by 2 pi. So I have 10 pi, and I'm going to subtract 2 pi a total of 5 times. 5 times 2 is 10, and 10 minus 10 is equal to 0. So add 0. So 0 pi, which is just 0, that's going to be at the origin. And I see that at the origin, so at the origin, let me do it in red instead. That's located right there. So the y value equals to 0. So finding f of 10 pi is the same thing as finding f of 0, which equals to 0. So that's your answer. Now in this next example, again, we don't go as far as -5 pi. So what I'm going to do is that I'm going to add the value of 2 pi instead of subtracting. I'm going to add it this time, and I'm going to add it 2 times. And let's see if that works. Well, 2 times 2 is 4, and -5 plus 4, that equals to -1. So -1 pi, which is just the same thing as -pi. Well, I see again here, so f of -pi. So I see here that when the x value is -pi, the y value is also equal to 0. So this right here is our answer. And now finally the last one. Well, if you notice again, if you've been paying attention just to what the two examples that I have, you'll notice should noticing again that anytime I am subtracting a multiple of whole numbers of pi's, even though this one didn't multiply, it's still in the remainder, my answer at every whole number value of pi is always going to be 0. At a fraction value of pi over 2 specifically, at every half value of pi, whether it's 1 pi over 2 or 3 pi over 2, the y value is going to be either +1 or -1, depending on, again, which value we have. So here, since I have 9 pi over 2, I know my answer has to be either negative or +1. So let's see which one is going to be. By subtracting, let me zoom in here, by subtracting 2 pi from this 9 pi over 2. So we have 9 pi over 2. And I want to take away 2 pi. Let's do it 2 times. Let's see if that works. So 9 pi over 2. And this, remember, is the same thing as 2 pi. This value right here, 2 pi, is 2 pi over 1. And since I need the denominators to be the same, I can multiply the 2 pi with 2 over 2, which would be 4 pi over 2. So all I've done is just simply write my 2 pi over 1 as the fraction, as the ratio of 4 pi over 2, which is equivalent to that. And if I multiply that by 2, so let me erase this, and let me write this as 4 pi over 2. So if I multiply it by 2, that's going to be 8 pi over 2. And now 9 minus 8 is equal to 1, so 1 pi over 2. So finding f of 9 pi over 2 is the same thing as finding f of pi over 2, which we can now look at. We see that here, and that's here. Where the y value is positive 1. So that's our answer.